Good morning, good evening, and good afternoon, folks. So let's give me 1 more minute. Then we can start. So by the way, who from the Xflow will present?
Hi Enzo, it's Hamna from Xflow and I will present today.
Okay. I think you can share your screen. So,
Okay. Is my screen visible?
uh, yeah, I can see your screen.
So let's start. So
Yeah, go ahead.
okay. So today I will present the multiple spanning tree protocol HLD and SONiC that is contributed by Xflow Research. So this document describes the high-level design of multiple spanning tree protocol. A little background about this HLD: it is based on the design provided by PVST HLD and the link is mentioned here. So moving on to the introduction of MSTP. So PVST supports STP by running separate spanning tree instance for each VLAN. But the problem is it consumes more resources and all instances are complex to manage. So here comes MSTP that supports the mapping of one or more VLANs to a specific instance. So this provides an efficient resource consumption as compared to PVST. And in MSTP, there are MSTP instances that operate within MSTP regions, and there are separate spanning tree instances handling specific VLANs that are mapped to it, and all those VLANs that are not mapped to any instance are by default mapped to the internal spanning tree. And then there is a common spanning tree that facilitates the interconnection between all the MST regions. And lastly, there is common and internal spanning tree that basically uh, that basically combines the internal spanning tree and common spanning tree to span the entire MSTP domain. So uh, this is the MSTP bridge protocol data units that are used for transfer of MSTP control information. And then there are MSTI configuration messages that are included in the BPDU right here, and all the details of these BPDU fields are mentioned in this RFC that I have linked to. So next, moving on to the requirements. First is to support the creation of multiple spanning tree instance. Second is to support the assignment of one or more VLANs to specific multiple spanning tree instance within a region. Thirdly, we need to support the option to assign a region name and revision number to MST regions in order to achieve a unique identification of VLAN to instance mapping across switches. And fourth one is to support path selection and forwarding behavior in MSTI in order to optimize the network performance within each instance by configuring a distinct route bridge. And then we need to support the configuration of some timers that are spanning tree parameters such as forwarding delay, hello timer, hop count, and max age. Then the destination MAC address for MSTP BPDU will be this right here. And lastly, we need to make MSTP compatible with other spanning tree protocols such as STP, RSTP, and PVSTY protocol migration. So I'll stop right here if someone has any question. Okay, so let's move to the architectural design. So this is the basic architectural diagram that I have made. So firstly, starting off with the CLI user, whenever the user make any MSTP configurations, these are added indirectly to the config DB. Then there is a STP container running. It has STP manager and STP daemon process. The MSTP manager receives all the configurations from the config DB. It has subscribed to all of the MSTP tables, and then it also receives the state from the state DB as well. So then it parses all these configurations and pass on to the STP daemon. So STP daemon is where all the protocol is running, and all the protocol related configurations, timers, all is dealt by this STP daemon. So it also deals with the BPDU TX and RX, and also it receives the port and lag state by netlink events. And then there is another module, STP sync D. This is responsible for adding all these operational states that STP has just calculated into the application DB. Then in the SWSS container, there is STP org agent. So basically what information it receives is, first is the VLAN to instance mapping, then the port state in a specific instance, then if the FTP flush is needed or not. So upon receival of all these information, it configures all the SCI attributes into the ASIC DB that calls the SCI APIs. So this is the all the detail that I have already discussed. And another thing is about the COP configuration. So as I have mentioned that MST uses BPDUs as its control packets. So in order to trap these BPDUs, the COP will be extended to include a new entry of MSTP trap ID right here. And yeah, if anyone has any question regarding to architecture. Okay, let's move forward to the database changes. So firstly, starting with the config DB. So we have a table, STP global table. So it has a field of mode. Another value of MSTP will be added in order to support MSTP mode. Then a new entry of maximum hops will be added into this table, and this table also has some of other fields like root card timeouts and other timers like forwarding delay, hello time, and max age, and they will also be used to hold MSTP related configurations from the CLI. And moving on to the new tables that will be added as a part of MSTP. So first is the MSTP region table. This this has all the region related information like region name and revision. And then is the MSTP instance table. So it contains key instance ID is the key, and it stores the bridge priority in this particular instance. Next, MSTP VLAN table. This stores all the VLAN to instance mapping that user has done by the CLI, and VLAN ID is the key, and it stores the corresponding instance ID. So then we have instance port table. So this stores the interface details of MSTP per instance. So the key is a combination of instance ID and interface name, and it stores the particular port priority and the port part cost. So next is the application DB. So the new tables that are introduced, one of them are MSTP region tables. So it will store all the region related operational details. For example, the region name, the revision, the bridge ID, the syst root bridge, the external path to this bridge, then root port, and the root related timers like max age, hello time, etc., and also the bridge timers itself. And these three fields right here are used for in order to give user the statistics of the region. And next is MSTP instance table. So in this table we will have all the instance related operational details. So it has VLANs, all the list of the VLANs that are mapped to this instance. Then there is an operational status, whether the instance is active or not. An instance is active only when it has VLAN that has a VLAN member. So basically, if there is a port that an instance can map to. And then there is the bridge ID of this particular instance, the regional root of this instance, the internal route path to this regional route, and the root port, and lastly there are two of these parameters to for statistic purpose. Next is MSTP port table. So this stores all the interface details per instance. So the port number, the path cost of the port, the port priority, the port state, port road, and designated route, designated cost, the designated bridge, designated port, and all of these parameters for statistic purpose. So next is the existing tables. So these three are those tables that Orchigent will subscribe to. So first is the STP port state table. So basically these three of the tables are already implemented as a part of PVST. So first is the port state table. It will hold all the it will hold the state of the port with respect to each instance, whether the state is forwarding, learning, or blocking. And then second is STP instance table. It holds the VLAN to instance mapping. And lastly, there is fast staging flush table. This is used to inform when the FTP flushing is required. So this is done in case of topology changes and the entry is added by the syncd in the application DB. So I'll pause here if there are any questions from these tables. Okay, let's move on. So then we have a section of SCI API. So these I have mentioned here are the existing SCI attributes that will be used. So first is the STP instance component. It will have a list of all the VLANs that are mapped to it, then the bridge ID, and then all the ports that are being utilized in this instance. Then second is the STP port component. So it has first attribute is of STP instance itself that we have defined here. So the instance to which this port is currently mapped to. And then there is a bridge port attribute, and then the port state. So the port state has three values. First is learning, then forwarding, and blocking. So in VLAN SCI API, there is also an attribute for STP instance. So this right here can hold the STP instance that is made here. And then some of the switch STP attributes. So first is the default STP instance ID. And second is the maximum number of STP instances that a switch can have. And in order to support the trapping of MSTP, BPDU, a new SCI host interface trap type MSTP will be introduced in SCI host interface module in order to support the trapping of control packet. So are there any questions from SCI? Okay.
One question here, sorry. Why do you need a new trap type for the MSTP packet? Shouldn't the existing STP trap work for this? The packet's DMAC is going to be 0180C2 all zeros, right?
Right, but MSTP do have a different BPDU format, so I think we would need a different control packet type.
No, the device might not go and identify the differences, right? The device will do based on either type, or in this case, just the MAC address, right? The device would not look at other. Okay, maybe I think this should be discussed in the SCI committee, right? And then come here.
Okay, I'll discuss in SCI and then comment in the HLD if needed.
Okay, yeah. And can you just explain how is the default STP instance ID used? Such STP attribute default.
Yeah, so all of the instances that a user does not explicitly mention that all the VLANs that a user does not explicitly map to any of the MST instance are added into this default STP instance. So
okay.
yeah. So
does it map to whatever the internal STP? You were talking about something like an internal STP instance.
Yeah,
right?
yeah. So
okay.
So the internal spanning tree is the spanning tree that will be formed against this attribute in MSTP.
Okay, yeah, thanks.
Okay. Any other questions?
Hey, can you hear me?
Yes.
Hey, I was not audible. Okay, can you just go up and the starting of the global, the spanning tree mode? We have one more option, disable. So
Yeah.
tell me why this option is required.
Yeah, so actually, we do have a CLI command to disable the STP mode, and this attribute right here is added. So in order to say that no STP is running at the moment, so we do need a disable value.
For PVST disable, we don't have a disable option, right?
Yeah, but then how can you say that, right, if any of the STP mode is not running, then how will it be depicted in the config DB?
The entry will be deleted, right? The DB will be deleted, right? If no entries are there. That way
Okay.
PVST is taken care. Okay, I don't think we need an like an extra variable here.
Okay. I was not entirely sure about it, so I will look into it and delete this here if
Okay.
needed.
Check. And can you just go up to the require? I was not audible. Okay. So
Okay, no
I was
problem.
talking actually.
Requirement?
Yeah, I see the PVST via protocol migration. I don't
Yes.
think PVST can talk to MSTP. I obviously STP and RSTP can talk to MSTP, but not PVST because it's all tagged, right? Only untagged VLAN is there, it can talk. So it's not PVST.
So
Okay. STP
what
and MSTP.
So what happens in MSTP? If any other flavor of STP is running, it consider it as a different region. So it will. I think it can talk to PVST. I mean, I have checked Cisco's MSTP, and it is backward compatible with PVST. So I think it should work.
Please check, but whatever I know, PVST is for VLAN. MSTP is not
Mm-hmm.
for VLAN. It is
Yeah.
all untagged video. So untagged video can't talk to a tag. I mean, it can't identify the tagged videos. PVST is tagged videos, right? Right?
Yeah.
Okay,
Mm-hmm.
please check that. Okay, and
Yeah. Okay. I'll check.
come down. So
Okay.
also, I don't see the support for like we have this BPD guard, BPD filter,
Mm-hmm.
root guard, and you haven't added any like are we, no, you're not supporting that.
Yeah, actually, all the CLI commands and all the table related information were already covered in the PVST databases and the CLI command. So that's why I have not mentioned it here again.
So you mean to say that that STP global table will be valid here also for all the configurations?
Actually, this table, we are adding two new entries. These are the other values that will also be valid for MSTP and PVST as well.
Okay, but at least we have to add in the requirement section, right? Even if we are not adding it here.
Okay. Mm-hmm. Okay, good point.
Yeah.
Highlight.
Okay.
Thank you.
Can you please come down? I have one more question. So, yeah, hold on. Just go up. So here, right, the instance to VLAN mapping, MST VLAN table, right?
Mm.
So if we have like this one VLAN and one instance, right, we are going to have 4K entries. So can't
Yeah,
you,
right.
guys, right?
So one other approach can be that we can add a list of VLANs in this instance table, but the problem is when you are going to delete a VLAN, then you have to then traverse over all the instances and all the lists that are stored in front of those the VLAN entry. So I think that would be more time consuming. So that's why I've created a new table for it.
Okay, what I mean is that is the more optimized way, right? Instead of having 4K entries, we can just
Mm-hmm.
have like the number of instances, say 64 now, this table will be only 64 instances.
Okay, I'll discuss with my team and change if you know that.
Also, see, you don't allow the pre-provisioning of VLAN.
Sorry.
Pre-provisioning of VLAN, right? Without VLAN, you can't configure MST2 VLAN mapping, right? You have a limitation.
Sorry, can you repeat your question?
So VLAN to instance mapping,
Yeah.
there, right? You need to configure the VLAN before the instance mapping, correct?
Yes. Actually, this check is being added into the Yang model, right? So the VLANs that are configured only, they will be added. They can be added into this table.
Okay, I mean, if you do like that, right? One VLAN addition, deletion, all are going to make a lot chunk of change, like convergence changes when you add just one VLAN into an instance. Correct, no?
Mm-hmm.
I mean, if you don't allow pre-provisioning, that is going to happen. So if you just add a VLAN, right, and you
Okay.
make a big change.
Okay, Divya. Hamna, let me take this. Okay, Divya, I didn't understand your point. We will update it accordingly.
Yeah, thanks. Thanks.
Thank you.
Okay.
Hey, question. So then, this MSTP, then are you dependent on the previous submission of PVST, which is still in which has not been merged yet? This was posted a while back, 2019.
Yes, Aram. Basically, this is something we need also to be addressed, that some of the code that has been placed by PVST is dependent by MSTP. So we are just seeking guidance from the community and Broadcom on this as well.
Yeah, so then I think if you have the dependency, we need to work together to make sure the
Yes.
previous one actually got in.
Yes, I agree. We can decide and have an internal discussion for it as well. You can just put your comment on the HLD as well, and we will plan for an internal discussion on it.
Yeah. Okay. And you know, just for I would also want to let you know that we're also working on a MSTP proposal. So anyway, so go ahead and finish the presentation, and then once the version of the MSTP from our side is ready, we can also have a review, and then we can discuss
Okay,
about the
yes.
conversions.
Yes, perfect. We can just firstly review our HLD, and firstly we will consider the code dependency of PVST, and sooner when you will be updating your HLD and when it got be reviewed, we will decide on it. Okay?
Yeah.
Thank you.
Good. Thank you.
Okay.
Yes, please go ahead.
Okay. So moving on to the sequence diagram. So we have first diagram is for MSTP global enable. So whenever the user gives the command of enabling MSTP, it creates MSTP region instance 0, that is the default, and maps all the VLANs to instance 0 and enable MSTP on all the ports. So this is then gets notified in STP manager, which gets all the VLAN member ports, and it then enables global gets enabled in STP daemon, and all the default region parameters are set. Instance 0 is created and all the VLANs are mapped to it, and all ports gets also enabled for MSTP, and STP instance ports are created. Then all this information is added to the application DB. Org agent is notified, and it creates STP ports, map ports to default instance, and set port states.
Okay,
So
I want to mention it as map port to the CST instance. That's the right thing. Okay, the system may have a default one, but we need to map it to the CST instance.
okay, good point. So the disable is quite similar, so I'll skip it. So next is to change the MSTP region name and revision. So the user configures to change this region related parameter. It is notified in the STP manager. These region related configurations are updated in STP daemon, and this is added into the application DB. The origin gets notified, and also whenever the region name or revision is changed, the port states are changed to blocking at first. So this is then updated into the SIG DB. Next is instance creation. So whenever the user creates an STP instance, it gets into the config DB, then STP manager gets notified, and instance is created in the STP daemon. Then the instance entry is added into application DB, the origin gets notified, and lastly it is created in the ASIC. So this instance deletion is quite similar, so I'll skip it. Next is to add VLAN to an instance. So user gives the command to add VLAN to an instance. This configuration gets into config DB. STP manager gets notified, and it then fetches all the VLAN member ports. This is then add the then VLAN is added to the instance in the STP daemon. This information is then added into the application DB. The origin gets notified, and in the ASIC it maps VLAN to instance and update the port states accordingly. So delete instance is again quite similar, so I'll skip it. Then the updation of port state, the topology change, and instance interface related events remain same, and these all are present in the sequence diagram in the PBST HLD, so you can refer to that. So moving on to the configuration commands. So these are the commands. So firstly, we have added a new value for MST right here, and second is the new command that will be used to configure the maximum hops. Then the region level command, first is to configure the region name, then to configure the region revision number. Then instance related command, this command will be used to add or delete the instance. Then to configure the bridge priority in a particular instance, and then for VLAN to instance mapping, this command will be used for adding or deleting a VLAN in a specific instance. Next is the instance interface level commands. So first is to configure the port priority in a particular instance. Then second is to configure the path cost in a particular interface, in a particular instance. Then comes the show command. So firstly, we have this command show spanning tree. This is already present, and the output will be like this for if the spanning tree mode is MSTP. So we'll have firstly the region parameters, then the instance to VLAN mapping and all the instance related information, and all the port related information in a particular instance. Then we have separate commands if the user wants to see just the region related information, then show spanning tree region can be used, and if a user wants to see only information related to only one instance, then show spanning tree instance, this command can be used. And similarly, for a particular instance, for a particular interface in an instance, this command can be used. Then for statistics, in order to show the statistic of a particular instance, this command can be used. Then to clear the statistic, for clearing statistic on the basis of instance, and second command is for clearing the statistic on instance interface level. Then debug commands, so debugging and on the basis of region, then on the particular instance. Then for displaying internal data structures, there will be dump commands. So this right here for region, then for instance, and for a particular instance, particular interface in an instance. Then these are some of the commands that were uh, added as a part of PVST for VLAN level configuration. So in MSTP, we don't have VLAN level configuration. So all these VLAN related commands will be disabled if spanning tree mode is MSTP. And also the above commands of data region level and instance level commands that we have added as a part of MSTP, they will be disabled if spanning tree mode is PVST. So I'll stop here if someone has any question regarding these commands.
This show command is having an uplink come down.
Where?
Yeah, uplink fast, port fast.
Yes.
Wording port fast is right for PVST, but
Yeah.
MSTP and all it is edge port actually.
Yes, and also I think I missed this thing. Uplink fast is not compatible with MSTP. So in MSTP we don't have uplink fast.
Yeah, also
So
port fast it is edge port. Okay,
okay.
standard.
Okay,
Okay,
but
but
I think both of them are same. So I think naming convention should be followed. If in PVST we have port fast, then in MSTP it should be same. No?
No, MSTP it is edge port. MSTP and RSTP it is part of standard, IEEE standard and called as edge port.
Okay.
You should
Thank
have
you.
a configuration also for that to do a non edge port or non edge port, and there should be a CLI for that also.
Okay. Any other comment? Okay. Let's move towards the Yang model. So I'll just skim over it. So starting with the STP container. So first is for the STP global. It has a leaf of mode with these values. Then forwarding delay, that is a timer. The range and all the default values are also mentioned. Hello timer, the max age, the root card timeout, and the bridge priority, the max hops. Then second container is for MSTP region. It has all the region related details. So first leaf is for region name, then for the region division, and the default values and the type are also mentioned. Then we have a container for MSTP instance. So it has a list of MSTP instances. It has a key that is basically the concatenation of instance with the instance number. Then the bridge priority in a particular instance. Next is for MSTP VLAN. So there is a list for MSTP VLAN that has a key of VLAN. So this must condition checks that if the VLAN is already present in the VLAN Yang model. Then the instance ID the VLAN is mapped to, and this condition checks that if the instance should already be created. Next is MSTP instance port container. It has a list of instance port, and it has a key that is a concatenation of instance and the port number. So the leaf of instance, this checks that instance should be present, and then the leaf for a port, and then the priority of the port and then the path cost of the port. So this was the Yang model. So are there any questions from this? Okay, let's move on. So REST API is out of scope for this HLD. So warm reboot will not be supported because the IEEE standard of MSTP does not define any potential way to support it because it might cause loops in the network. And if a user tries to do a cold reboot when MSTP is running, uh, then an error message is displayed and user will first need to disable MSTP so that the topology reconverges and all the parts are reevaluated. So I think these are the test cases, and I think that's it for the HLD. So lastly, we have the references. So are there any questions from?
Okay, thank you, Xflow team. So for
Sorry,
the
I saw there were some comments in the chat window say if there are any changes to the portal cage. Do we have a component design doc, on how this cage just works? You know.
So most of the functionality will remain um, same if we talk about the org agent, and it is mentioned right here. So the creation and deletion of instances, the VLAN to instance mapping, and the assignment of port state, and lastly the FTP flush. Most of this is taken care as a part of PVST, so I don't think there will be much change for MSTP.
So no change to the port talk, or you're only going to introduce this HTTP org, but there's no change to the port talk, or?
No, the port origin will not have any changes. All the changes will be in STP.
Yeah, how do we handle port breakout? I mean, if we do a port breakout, then how does this work for the STP?
So they are handled by the VLAN to port mapping by the VLAN members.
Yeah, for example, if we add a new member in the VLAN, how does gets notified and added to the STP org? Do we have a flow for that, or?
So whenever a new
No
VLAN
VLAN member is
So whenever a new VLAN member is added, so basically the STP daemon gets notified. We do have right here the VLAN state that is coming from the state DB, and the STP manager gets notified, and then it notifies the STP daemon if there is any change in the VLAN.
Oh, is there a workflow on this specific case, or
You mean?
you have several flows, and I didn't remember. I saw if a member gets added or deleted, we have that.
So for this particular case, we don't have it right now, but we'll add it.
Okay. Okay. And what about the admin shots, those things? Also, you will get notified somewhere?
Yes,
port
we,
state change?
yes, the netlink events that I have discussed right here, they will deal with all the port state changes that will be taken from the kernel directly.
Oh, why is that? I thought we have a, why not subscribe the StateDB? Why subscribe from the kernel? I saw
So,
the communication. Yeah.
yeah, so this thing, this is in accordance with the PVST. So this is how they have mentioned in their HLD that they will be using netlink events for all the port and lag related, information, the up and down of ports. So I think we will be building on top of that. So we won't be changing any existing configurations.
So, Gohan, do you have any specific concern related to this? If so, then can you please add your comments on the HLD? We can just discuss this with Broadcom and then work on it in collaboration.
Okay. Which HLD? I mean,
This is
I
MSTP.
was because they said okay, it depends on the PVST. Do I comment on the
Yes.
PVST
No,
design doc
please
or
kindly,
comment here?
no, kindly comment on the MSTP doc.
You're on this current doc, right? So
Yes, yes.
okay.
Any further comments?
Oh, I was just wondering like how the port breakout will work. In this case, do we talk about that flow or no?
Okay.
Gohan, in
this is-
case of port breakout, I think the configurations will be removed from the port, right? So any new configuration like adding to a VLAN should be made by the user explicitly. Existing configurations will get removed.
So we will not be able to do port breakout unless we, remove the whole STP instance for that.
Yes, or
which
do you do a force breakout where the configurations will be removed based on the Yang dependencies? If the Yang dependencies are in place, I think the STP configurations will get implicitly removed on force breakout.
But which one will be removed? Because I think if we're thinking about like, okay, hey, I need to break out one port, right? So in that case, we can't, I mean, it doesn't make sense to remove the whole STP instance for all the.
No. Not the whole thing, the only thing that's associated with the port. Maybe if you can go to the Yang model, if you see what's the dependency on the port of SONiC port, only those things will be removed.
But isn't that remove will create some kind of unsafe operation, or we should really bring the link down and then do something like that in order to do that? Because I'm a little bit let's say the port that actually going to be breakout is kind of I don't know, like a root port or the port that uplinks in terms of STP. If we just remove it, I don't know what happens, or maybe we should disable it internally or somehow, and then do the port breakout to let the STP to converge or those kind of things. Or I'm just, yeah.
I see.
Basically, Gohan, it happens when their breakout for one specific port, only then that specific port will be deleted, and the uplink related to that port will be deleted. Do you understand, Gohan?
Deleted from where? Deleted from the STP instance, or?
No, basically it will be deleted. It will be deleted from the port instance because that port will not be currently part of that instance. Then it will be deleted from STP. specific one VLAN. And when MSTP
Okay,
is providing,
who will delete that? Or is this user will delete that, or there's some other manager will delete that when you're doing the call breakout, or how,
no,
what?
okay. Basically, if specific, if user have some made some deletion on some specific port, that specific instance will be deleted. You can put your comment on the HLD as well.
Okay.
I'll address it
But
here.
maybe
as well.
I mean on the higher level question. Okay, if I understand, okay, we have this STP MSTP proposal. We have a previous PVSTP, and what it seems I'm hearing that there is going to be a new MSTP proposal coming from the Broadcom, and they have interdependencies. So, so what is the path forward? We need to first, work on the PVSTP, get that. What are the dependencies identified? So we'll get that first merge, and then this one, and then the Broadcom one. I think what is the coordination between these three?
Okay, basically this design, I will first request Adam to answer this one.
I think PVST, you have a dependency on it. So the fact is, I mean, the submitter from Broadcom has already left. We have to revise these PVST code PR again, probably resubmit, and then from there we can work it out to see how to coordinate these sort of changes for PVST. And then for the MSTP proposal coming from Broadcom, I'm scheduling a time slot for community review, so we can have these also be reviewed by the community. And then after review, then I think between Expo and Broadcom, we can have a subgroup meeting to see how we can converge on this. And but I think the priority is actually set to PVST to actually get this sorted out, to have the PVST to be
Yes.
in shape for merge.
Yes, basically this design needs some code dependency for PVSTP. All we need from Broadcom currently, that the code PR that are not merged needs to be merged so that we can move forward for the design. And for the MSTP HLD that Broadcom is currently working. Yes, they can.
But I guess in terms of design, is I think it's totally fine to actually have these design to be reviewed while the PVST is still in the rework. So yeah.
Yes. We just need currently PVST unmerged code need to be merged for the MSTP requirements.
Do you have a list of PVSTP PR that you depend on? Somewhere you listed, maybe on this design doc, you listed all the dependency PRs that you list on, and let's check what is the status for those PR. Do you have that?
Yeah, there are 3 unmerged PRs. One is in the build image, then in utilities, and third one is in SWSS. And I have the link, and I will mention in the HLD PR so that you can get to those PRs and check the status with the reviewers.
Okay, so you have that PR, and
Yep.
And in terms of a difference, right? So I also remember on the PVSTP there is already a design doc, and I look at your show comments, all this, trying to understand, are these all the schemas you designed are new, or it's a D from the PVSTP, or do we use any of the schemas they have designed in the PVSTP, or no?
So Actually, we do have a dependency on the PVST code itself, but MSTP is a totally new feature. It introduces different schemas that I have already talked. It too uses some of the tables of PVST, and each one is already mentioned. So yes, we do need the code of PVST merge in order to MSTP to work properly.
Okay, could the system be configured into a state where some ports are using PVSTP, some ports are using MSTP?
No, all the ports should have only one STP mode. Either it is PVST or it's MSTP.
Okay, do we have a configuration tree to indicate that? Like which
Yes, we do have a global table right here. We have a mode attribute that can be PVST or MSTP, either of them.
okay. So this is the global mode, right? So okay.
Yeah.
And this STP is by default disabled?
Yes, it is, because all the ports are in layer 3 mode, so that's
I also remember there is a layer 2 mode, but I mean, if we configure the layer 2 mode, is also STP by default disabled?
no.
Okay. So where do we specify that? Like what is the default mode?
So we do have a Yang model validation where we define the default value for the mode. So the default value is disabled.
Okay, so default is disabled. Okay.
Yes.
So Adam, do you have a? I remember you say you also have a STP proposal. Do you have a date on that or?
Talk about MSTP.
Yeah.
Yeah, so we're looking to have this post in 2 weeks.
Oh, in 2 weeks.
Yeah, and then looks like Yansao availability list, maybe, you know, I think the next available slot to review is actually out from 2 months.
Okay, let's check with Yanzhao. Yeah, so.
Okay, Adam, you can also put your comments on the HLD so we can further decide on how we can work together.
Okay.
Rohan, do you have any specific concerns? Actually, the time is running.
No, I'm good. Yeah, so thanks.
Okay. Okay, thank you, everyone.
Bye.
Okay, thank you, team.